The second half of chapter 4 talks about inventory management. So, why and how do we manage inventory? There's a lot of decisions we have to make with inventory management, but the main two being what inventory do we carry and how much of that inventory do we keep on hand? Our goal with inventory management and how much inventory that we keep on hand is to maximize customer service and to minimize costs. So, what is the bare minimum of inventory that we can have on hand in order to make sure that our customers are happy? We maintain that customer service policy, but we're not paying extra costs. There are a variety of reasons to hold inventory. One is for transportation economies of scale and production economies of scale. So, economies of scale are when we start saving money as we increase the quantity of the amount. So, an example of a transportation economy of scale is that we order enough inventory to fill an entire truck. If we have to pay a flat price for a semi truck or for that truck to ship, then we want to make sure it's as full as possible. Why would we pay for air? For production economies of scale, again, the more we produce, the less it costs per product. So the more we produce, the less it costs per product. We have incentive to produce more inventory. Economies of scale in purchasing. So this is like bulk purchasing discounts. If you buy one, it costs this much. If you buy 50, we'll give you a discount. If you buy 100, we'll give you an even better discount. And if you buy 1,000, we're going to give you the best discount that we can think of. Okay? Preparing for seasonal demand. So we're stocking up because that season is going to start and we need extra inventory. So we need all the Halloween candy at Halloween or Christmas trees in November and December. New product introduction. We're getting ready to launch a new product and we want to make sure that any customers that come to that launch have a guarantee to get a piece of that product. So we don't want to run out. So we're going to do a mass inventory supply for that to maintain a regular source of supply. So we just want to hold inventory to meet the demand of our customers and support that customer service policy. But how much inventory depends on a variety of things. So we want to make sure that we have enough inventory that we're making our customers happy, but at lowest cost. So we have to do a trade-off there. So the trade-off is usually between like how much does it cost to order inventory to the administrative costs with issuing an order, transportation costs, warehousing costs, versus how much does it cost to hold the inventory. So how much money do we have tied up in the inventory that's waiting to be sold? We don't recoup that cash until we sell it. So if we pay a bunch of cash for, we buy bulk inventory, we buy 1,000 even though we need 100 because we're getting this great discount, we don't get that cash back until we sell all 1,000 of them. So we tie up capital in our inventory. We have to store it, we have to insure it, we have to we might have it might get damaged, it might get spoiled, it might get stolen, it might become obsolete, and then we don't recoup the money on it at all when those things happen. So when to order inventory? This formula is called the economic order quantity, and it determines the order quantity that minimizes the cost of ordering and the cost of carrying inventory. So when we look at a constant level of annual demand, larger orders mean fewer orders, which reduces the ordering cost. However, larger orders also mean more inventory, which increases inventory carrying costs. So the components of this economic order quantity quantity are how much do we pay per order? What is our annual demand? What is our annual inventory carrying cost? And what is the average cost or value of 1 unit of product? So we look at an example of this. So we have a company that purchases 7,200 yards of hemp per year. The value of each yard of hemp is $100. It costs $70 in administrative costs every time we issue an order. So administrative, transportation, logistics, and the carrying cost per year is 25%. So we look at order cost, $70. Total demand, 7,200. So ordering cost demand times 2, and then we divide that by the per unit value times the carrying cost per year of per unit. So we get that our economic order quantity is 200 units. This means that we should order in quantities of 200 units or 200 yards of hemp each time we place an order. So then that results in 36 orders per year. So our annual demand is 7,200. We'll do 200 per order. That's 36 orders a year. So we should order every 10 days, 365 days in a year divided by 36 orders. We should order every 10 days. The lowest cost is to order 200 units 36 times a year or to place an order for 200 units every 10 days. So this next slide shows a cost trade-off. So this is also back to our hemp order. So you can see here at the 200 order at 36 orders a year, our order carrying costs and our order inventory costs are almost identical. One is not greater than the other, and our total cost is the lowest of any other option on this table. You can see that if we order 800 yards 9 times a year, we have our lowest ordering cost, but we're going to pay our highest carrying cost. Same thing. If we order 50 yards 144 times a year, we're going to have the highest ordering cost, but our lowest inventory storage cost. So what the goal is to minimize the cost. So you can see on this chart, total costs are minimized when ordering costs and inventory costs intersect. So that's at this point. If we graphed out those amounts, this would be those 200 yards of hemp where our ordering costs and our inventory carrying costs intersect. Okay? Some assumptions with the economic order quantity formula, though, is that there's no uncertainty in the demand for our products. We know our demand and it's constant. Lead times are constant. What the lead time is how long it takes to get from our supplier to us when we place an order. So how many days, how many hours. It also assumes that our shipments are never late and that our transportation costs per unit are fixed. So this means we don't pay extra when gas prices go up, or we don't pay extra for other services. There's no interaction among different items, no limit to the availability of capital. So we have all of the money, warehouse storage we need in order to order things whenever we need. And it doesn't explicitly consider the replenishment lead time. So thinking about what that lead time is and how long it takes to get products to us. So instead of using the economic order quantity, we can use a lead time demand quantity. So this is ordering just enough inventory to support operations until the next scheduled delivery. This minimizes inventory carrying costs because we have just enough inventory on stock to meet daily demand. So where the amount that we order is determined by how long it takes us to get stock from our supplier and our daily demand in units. So why use lead time demand? Okay, it minimizes the risk of holding inventory, so risk of obsolescence, of theft, of spoilage. Um, it works really well for certain industries where inventory goes obsolete or spoils very quickly. So another reason is because ordering cost is not really a factor anymore because we do orders online and we use technology. Ordering costs are decreasing. They still, the lead time still assumes no uncertainty, which is not realistic because trucks are late, demand is not constant, and prices vary based on quantity. So to manage any uncertainty, we can look at inventory in two different components: base stock and safety stock. So base stock is the stock that we need on hand just to maintain our daily operations and our customer service goals. Well, safety stock is the additional inventory needed to protect us from uncertainty. So uncertainty being as that the next truck is going to be late, or um, customers decided they were going to buy more than they usually do, so our demand was higher than we originally planned for with our base stock. Okay, so our base stock is just that straight inventory needed to support daily operations. We usually think about it on an average. Okay, so base stock is at its highest when we receive a delivery and gradually declines as product is used. We should be completely out of base stock right before the next replenishment delivery arrives. So if we look at these charts, this is our relationship between order quantity and base stock with order. So if we're looking at our order quantity of 400, then every time we order, so we always want to maintain a base stock of 200. So then we would order when it hits to 200. By the time it gets low that we might be running out, we receive another 400. When that gets down to 200, we're going to order again. If we have an order quantity of 20, then we need to reorder every time we hit 100. Okay? Safety stock is buffer stock. So this is stock that we maintain just to protect us from uncertainties of demand and replenishment lead time. Okay? So demand has increased, it's higher than expected, so we have excess safety stock on hand to make sure we don't run out while we're waiting for a shipment to arrive. If our shipment is late, that we have enough safety stock to cover as many days as we need until that shipment arrives. When we look at safety stock, we might have just a regular, we always have so much on hand just in case. And then we have average inventory and how our inventory level changes across a period of days. How much safety stock should we carry? Well, that depends on the demand, how long it takes stock to get to us, what our service level is for customers. So if we have a high customer service level, then we have a high safety factor where we want to make sure that we have a high amount of safety stock available so that we never run out of stock. So a factor is trying to determine what exactly that safety factor is requires determining the standard deviation of demand and replenishment lead time. So standard deviations, or z-scores, if you remember statistics, capture the variability in a series of observations. So a small standard deviation means we have similar observations, and a larger standard deviation means there's large differences between our observations. So when we look at these, the use of a standard deviation to quantify uncertainty is that two standard deviations are needed for each item of inventory. One, to look at the uncertainty of demand, and the other to quantify the uncertainty of replenishment lead time. So where we have the average replenishment lead time, so it takes 3 days for an order to reach us, or it takes 10 days for an order to reach us. The standard deviation of daily demand, the average daily demand, and the standard deviation of replenishment time. Our customer service level is defined as an inventory availability measure. So we may decide to adopt a customer service policy of 95% availability. So we want this probability of no stock out, so we're not going to run out, or we want to look at what our fill rate is per customer. Okay, and we're going to